To your question, so let's tackle it step by step. Let's take a step back and go to logistic regression because this is simpler to understand. After this, I'll come to softmax in a little while, but let me explain it from the context of logistic regression first. Right? So this is your logistic regression, right? What is the probability that yi equals to 1 given xi? This is nothing but yi hat, which is nothing but the sigmoid of w transpose xi plus b. Right? In the course videos, we may have skipped b just for brevity, right? And what is the sigmoid function now? Sigmoid function is this. Now your question in the case of softmax was, why are these values? Again, I'm taking a step back to logistic regression because I'm assuming you have understood logistic regression before you jump to softmax, right? So in this case, now your question is, why is this probability? Okay, let's simplify your question in the context of logistic regression. Why is this probability value equal to this function? Right? Why? How are they both equal? Now, there are two parts to it. When I'm training my model, when I'm training my logistic regression model, what are the things that I'm learning through an optimization function? I'm learning my W and B, right? So my whole learning of logistic regression, where I have log loss, again, if you recall logistic regression chapter, we try to minimize log loss between yi and yi hat, if you recall that, right? But the functional form of this probability equals to yi hat, and this probability is what is equal to this. Now your question here is, how are you making this expression, which is the sigmoid function of w transpose xi plus b, how are you making this whole thing equal to this? We are making this using the optimization of minimizing log loss, wherein we are learning w and b, right? So there are two parts to the question. How is this equal to this? We are learning our w and b such that through the process of optimization, stochastic gradient descent, etc., when we minimize log loss, we are finding that w and b such that this is as close as possible to these probabilities. Number one. So that's the first question. Second question is, why is this function in this form? Why can't it be in any other form? That's the second question. It is in this form, as we explained in our logistic regression chapter. We explain it intuitively and geometrically using the squashing argument. That's one part of it. The more fundamental, more rigorous mathematical interpretation of it comes from the probabilistic interpretation. If you derive logistic regression from probability, again, this is something that we discuss in our course videos in logistic regression. There is a video called probabilistic interpretation of logistic regression, where we come from Gaussian naive Bayes and we say we can derive that this is equal to this functional form. Remember, there is a functional form here. Why should this be sigmoid? Why can't it be tan? Why can't it be sine? Why can't it be any other function? Why is it sigmoid only? That's a good question, right? It is sigmoid because you can derive that this will be sigmoid from the probabilistic interpretation, wherein if you derive from the first principles of probability, right, using the Gaussian naive Bayes type of system, you can derive that this will be in this sigmoid form. This is nothing but the sigmoid function, right? So the reason for this form of the function, which is the second question, can be argued geometrically from squashing argument. It can also be argued probabilistically based on the probabilistic interpretation that we discussed in the logistic regression chapter, right? I'm assuming you've gone through this. Then everything will become easy. Now, once the functional form itself, once this form of the function is decided, how are we making these two equal? That's the whole training process in logistic regression. We are finding that w and b which will make this as close as possible to this. Simple. Now, if you want to interpret this from a diagrammatic viewpoint, this is what it is. Again, I've taken this diagram from the course videos itself, from the softmax regression video, right? Softmax and cross entropy video in deep learning. The same diagram I've taken here. This is my xi input. What do I have? I'm learning these weights and this bias to my logistic function, right? This is what I'm learning. So I hope the first part is, why is this equal to this? Because we are learning w and b such that this will be as close as possible to this. That's the whole optimization problem we are solving. Second, why is it in this form? Because of the probabilistic interpretation, we can derive it using binomial random variables and Gaussian naive Bayes type of system, right? If this is understood, softmax is trivial. Softmax is a simple extension to this concept to multiple classes. So again, this diagram I've taken from the course videos itself, where I say we have 4 classes. This is my d-dimensional xi. This can belong to one of the 4 classes. So what happens? All these inputs are connected to one sigmoid here. All these inputs are connected to the second sigmoid, the third sigmoid, and the fourth sigmoid. These weights, look at this, all the blue ones, which are weights connecting the input to W1, those weights will be W1 and there is a bias term B1 corresponding to it. So there is a W1 B1 corresponding to it. There is a W2 B2 corresponding to it. There is a W3 B3 corresponding to it. There is a W4 B4 corresponding to it. And these weights are what we learn through minimizing cross entropy. Remember, when I want to train a softmax classifier, what do? I minimize my cross entropy. I minimize my cross entropy loss. And cross entropy loss is nothing but a generalization of log loss to multi-class setup. Right? These WI, BIs, W1, B1, W2, B2, which are all parameters of this sigma 1, sigma 2, sigmoid 1, sigmoid 2, etc. All these are learned by minimizing cross entropy. So your first question is, why is this probability? Why is probability of yi equals to 1 given xi equals to sigma 1 of whatever, W1 transpose xi plus B1? Why is this so? Why is this equal to this? It is exactly same as the argument that we have in logistic regression. How are we making this equals to this? By finding that W and B, by minimizing log loss, by solving an optimization problem, we are finding a W and B such that these W and B, such that this whole functional form is equal to this. Even here, we are finding W1 and B1 by minimizing cross entropy, by solving an optimization problem, we are making this equal to this. Similarly, probability of yi equals to 2 given xi and so on and so forth. The only thing is these 4 probabilities that we get here should sum up to 1. These four probabilities, because we have only 4 classes, given any data point, it has to belong to one of the 4 classes. For that, we make a simple adjustment, except that everything else is the same. Right? Softmax is a very, very simple extension to multi-classes, what we have for logistic regression in binary case. That's all there is.